Welcome to Space Sleep. Tonight, we will journey far beyond planets, far beyond stars, far beyond the limits of human imagination itself. Tonight, we will explore the true size of the universe. As you settle in for a relaxing journey, remember to like and subscribe Space Sleep for more peaceful journeys through space, time, and infinity. Now, imagine darkness. Not an empty darkness, but a living darkness, filled with worlds, stars, galaxies, and distances so enormous that the human mind struggles to truly understand them. Our galaxy itself is unimaginably enormous. The Milky Way stretches roughly 100,000 light-years across. A light-year, even the term sounds distant. A single light-year is the distance light travels in 1 year. Light moves at nearly 300,000 kilometers every second, fast enough to circle Earth more than 7 times in 1 second. And yet even at that impossible speed, light needs 100,000 years to cross our galaxy. If humanity launched a modern spacecraft toward the nearest star, it would take tens of thousands of years to arrive. The distances between stars are almost completely empty. If the sun were the size of a grain of sand, the nearest star would still be kilometers away. Galaxies are not crowded places. They are oceans of darkness, with tiny islands of light scattered across unimaginable emptiness. Now continue drifting farther outward. Imagine rising above the Milky Way itself. From this distance, our galaxy becomes visible as a soft spiral of light, turning slowly in darkness. Hundreds of billions of stars, blending together into glowing rivers. Nebulae drift like cosmic clouds. Black holes hide silently near the center. Ancient stars burn red and gold. New stars are born inside giant clouds of gas stretching across trillions of kilometers. And yet, even the Milky Way is only one galaxy, one among many. One among perhaps 2 trillion galaxies in the observable universe. 2 trillion. The number is so large that the human brain cannot naturally visualize it. If every galaxy were a grain of sand, there would be enough sand to cover entire continents. And each grain contains billions of stars, billions of worlds, possibly billions of civilizations, or perhaps only silence. Now imagine traveling beyond the Milky Way. The nearest major galaxy is Andromeda, a colossal spiral galaxy containing roughly 1 trillion stars, twice as many as the Milky Way. Even traveling at the speed of light, it would take 2.5 million years to reach it. The light entering your eyes from Andromeda tonight began its journey before modern humans even existed. Before civilization, before recorded history, that light crossed intergalactic darkness for millions of years, only to arrive quietly at Earth. Space is not only vast, it is ancient. When we look deeper into the universe, we look backward in time. Some stars we see no longer exist. Some galaxies may already be completely different. Their ancient light simply has not finished reaching us yet. The night sky is a museum of the past. Now continue farther outward. Galaxies begin clustering together. Massive cosmic structures emerge. Galaxy groups, galaxy clusters, superclusters. Gigantic rivers of galaxies stretching across hundreds of millions of light-years. The observable universe resembles an enormous cosmic web. Filaments of galaxies connected across darkness, like glowing neural pathways inside a giant cosmic brain. And between these filaments, there are voids, immense regions of near-total emptiness. Some cosmic voids stretch hundreds of millions of light-years across. If the Milky Way were placed inside one of these voids, the nearest major galaxy might be impossibly distant. Entire civilizations could exist there, never seeing another galaxy in their skies. only darkness, only isolation, only endless black space surrounding them forever. Now, imagine the observable universe itself. Everything humanity can see, every galaxy, every star, every planet, all contained within a sphere approximately 93 billion light-years wide. And yet, the observable universe may not be the entire universe. It is simply the portion whose light has had enough time to reach us since the beginning of cosmic expansion. Beyond that horizon, there may be vastly more universe, perhaps infinitely more. More galaxies beyond galaxies forever. The human mind naturally searches for edges, for endings, for walls, but the universe may not have one. Space itself may continue endlessly in every direction. No center, no boundary, no final destination, only infinity. And infinity is difficult to feel. Imagine counting numbers forever. 1, 2, 3. No matter how long you continue, there is always another number waiting ahead. Now replace numbers with galaxies, with stars, with worlds. The universe may be so large that every possible arrangement of atoms eventually repeats somewhere unimaginably far away. Some scientists believe there could be another Earth beyond unreachable distances, another version of you, another room, another quiet night, all separated by distances so enormous that light itself could never bridge them within the lifetime of the cosmos. And still, the universe continues expanding. Galaxies drift farther apart every second. Space itself stretches silently. The farther galaxies are from us, the faster they move away. Some now recede faster than light due to the expansion of space itself, which means there are galaxies whose light will never reach Earth, ever. Entire galaxies permanently beyond human observation, forever invisible, forever unreachable, and yet they exist. Somewhere in the endless dark. Now imagine shrinking once more, returning slowly toward Earth, toward the solar system, toward your quiet room. After seeing the scale of the universe, human life begins to feel different, smaller, softer. The worries of a single day become tiny compared to galaxies billions of light years wide. The universe moves slowly. Stars are born over millions of years. Galaxies collide over billions. Black holes wait patiently in darkness longer than civilizations can survive. Cosmic time flows differently from human time, and perhaps there is peace in that. Perhaps there is comfort in understanding that the universe does not rush. The stars are never in a hurry. The galaxies drift silently without fear. Everything unfolds gradually, across unimaginable spans of time and space. And now, as your breathing becomes slower and your thoughts become quieter, we will continue traveling even farther beyond the limits of known reality, beyond the observable universe, beyond the edge of human understanding, into regions where space, time, and infinity itself begin to lose all meaning, far beyond the observable universe, beyond the last ancient photons reaching Earth, beyond the faint glow of distant galaxies disappearing into cosmic expansion. There may exist regions of reality forever hidden from us, not hidden by darkness, but by distance itself. The universe expands continuously, and because of that expansion, some regions of space are moving away so rapidly that their light can never arrive here. No telescope will ever see them. No spacecraft will ever reach them. No message will ever cross the abyss between us. Entire realms of existence may remain permanently separated from humanity, not by technology, not by time, but by the structure of the universe itself. And still, those regions may contain stars, worlds, oceans, mountains, perhaps even civilizations looking outward into their own night skies, wondering if they are alone. Imagine standing on a planet orbiting a distant star in a galaxy so remote that the Milky Way itself is invisible from there. Not dim, not faint, completely unreachable by light. Humanity would not merely be far away. To them, we would not exist at all. And perhaps somewhere, right now, another mind wonders about the same silence. Another civilization asks whether intelligence has ever appeared elsewhere in the universe. Another species studies the stars, unaware that countless galaxies drift beyond their cosmic horizon forever. The universe is so large that isolation may be unavoidable. Yet strangely, the same vastness that creates loneliness also creates wonder, because within this immense ocean of space, matter somehow gathered itself into stars. Stars created heavier elements inside their burning cores. Those elements scattered across galaxies through colossal explosions called supernovae. Carbon, oxygen, iron, calcium. The atoms inside your body were forged inside ancient stars long before Earth existed. Every breath you take contains particles older than the solar system itself. Every bone, every heartbeat, every thought made from the remains of dead stars. In a very real sense, the universe became conscious through life. The cosmos learned to observe itself through billions of tiny living creatures opening their eyes beneath the night sky. And perhaps that is one of the strangest truths of all. Between enormous black holes, between galaxies separated by millions of light years, between endless regions of freezing emptiness, there emerged beings capable of wondering about existence itself. Tiny biological organisms, standing briefly on the surface of a small planet, attempting to understand infinity. And despite all human knowledge, we still understand very little. Scientists estimate that ordinary matter, everything we can see, makes up only around 5% of the universe. 5%. The stars, the planets, the galaxies, the oceans, the human body, all together, only a tiny fraction of reality. The remaining universe appears to be composed of mysterious substances called dark matter and dark energy. Dark matter cannot be seen directly. It does not emit light, yet its gravity shapes galaxies. Without it, galaxies would spin apart. Invisible structures may surround every galaxy like enormous hidden skeletons stretching through space. And dark energy, even more mysterious. An unknown force causing the expansion of the universe to accelerate. Galaxies are not merely moving apart, they are accelerating away from one another. The universe grows larger, faster, and faster every moment. No one fully understands why. Humanity lives surrounded by mysteries on scales almost impossible to comprehend. The deeper we look into the cosmos, the stranger reality becomes. Now imagine traveling beyond galaxies entirely, beyond matter, beyond stars, into the darkness between cosmic structures, intergalactic space, a region so empty that a human mind would struggle to tolerate its silence. No nearby suns, no planets, no glowing nebulae, only scattered atoms drifting across unimaginable distances. If a person floated there, the darkness would feel absolute, not like nighttime on Earth, not like a dark room. True cosmic darkness, a darkness untouched by atmosphere, clouds, or nearby civilization. And within that silence, time itself would begin to lose meaning. Days would not exist, neither would seasons. No sunrise, no sunset. Only endless stillness beneath distant galaxies appearing like faint islands of light. Even gravity becomes subtle in these regions. Objects can drift for millions, perhaps billions, of years without encountering anything at all. A lone atom may wander through cosmic voids longer than Earth has existed. Space is astonishingly empty, and yet Gravity slowly shapes everything. Tiny fluctuations in matter after the birth of the universe eventually formed galaxies. Galaxies formed stars. Stars formed planets. Planets formed chemistry. Chemistry formed life. Life formed memory, consciousness, dreams, civilization, all emerging from tiny differences in density shortly after the beginning of time itself. Now let us move backward, far backward, toward the beginning, toward the earliest moment modern science can describe. Approximately 13.8 billion years ago, the observable universe existed in an unimaginably hot, dense state. Not an explosion into empty space, but an expansion of space itself, everywhere expanding at once. There was no center, no edge. The universe did not grow into anything. Space itself stretched, carrying matter and energy outward. During the earliest fractions of a second, reality behaved in ways still not fully understood. Temperatures exceeded anything imaginable. The laws of physics themselves may have functioned differently. Time and space were compressed into conditions beyond human intuition. Then came expansion, cooling, particles forming, atoms emerging, light finally traveling freely across the universe. And billions of years later, stars ignited, galaxies assembled, worlds appeared. Eventually, on at least one small planet, life awakened. And now here you are, listening quietly in the dark, a conscious arrangement of ancient atoms, contemplating the universe that created them. There is something deeply peaceful about that. No matter how stressful human life can become, no matter how loud cities feel, no matter how overwhelming daily existence appears, above us, the cosmos continues moving silently. The stars do not panic. Galaxies do not fear tomorrow. Black holes wait patiently for trillions of years. The universe unfolds with enormous calm. Now imagine time moving forward instead of backward, far into the future. Millions of years from now, the continents of Earth will shift completely. Mountain ranges will rise and disappear. Entire species will vanish. The night sky itself will slowly change shape. Constellations familiar to humanity today will distort beyond recognition. And farther ahead, in roughly 4 billion years, the Milky Way and Andromeda galaxies will begin colliding. Not a sudden crash, but a slow gravitational dance unfolding over millions of years. Stars will pass one another across immense distances. Gigantic streams of light will stretch across the heavens. New stars may ignite from compressed clouds of gas. Night skies on future planets could glow with unimaginable beauty. And eventually, the galaxies will merge into one enormous structure. Long after humanity is gone, the cosmos will continue evolving. The sun itself will not last forever. In approximately 5 billion years, it will exhaust much of its hydrogen fuel. It will expand into a red giant, its outer layers growing enormous. Mercury may vanish entirely, Venus likely destroyed. Earth itself may become a scorched, lifeless world beneath an expanding, dying star. The oceans will disappear, the atmosphere stripped away, the surface melted by unbearable heat. And finally, the sun will shed its outer layers into space, leaving behind a white dwarf, a dense stellar ember slowly cooling across trillions of years. Even stars die peacefully in the end. But the future extends far beyond that, much farther. Trillions of years from now, star formation across the universe may eventually cease. Galaxies will grow darker. The brightest eras of cosmic history will fade. The universe will enter a long age of dimness. Ancient stars slowly burning out one by one. Black holes dominating the darkness. Civilizations, if any still exist, may witness skies almost completely empty of visible galaxies due to cosmic expansion. Future beings might not even realize other galaxies ever existed. The evidence will have drifted too far away. And farther still, black holes themselves may eventually evaporate through a process called Hawking radiation. Over inconceivably long timescales, even these giants may slowly disappear into faint energy. The universe could become colder, darker, quieter, approaching a state where almost nothing happens anymore. A thin, fading sea of particles drifting through eternal expansion. And yet, even then, reality may continue, perhaps forever, or perhaps new universes emerge from old ones. Some theories suggest our universe may be only one bubble among countless others, a multiverse, infinite universes with different laws of physics, different dimensions, different realities. In some universes, stars may never form. In others, gravity itself could behave differently. Some may collapse instantly. Others may contain structures beyond human imagination. The true scale of existence may extend infinitely beyond what humanity currently understands. And still, here tonight, you remain safely on Earth, breathing slowly, resting quietly beneath the stars. The room around you is calm. Your thoughts are becoming softer, and as the universe stretches endlessly outward, we will continue drifting deeper still, toward the strangest regions of reality, toward black holes, toward warped space-time, toward places where time itself begins to slow, toward places where distance itself becomes difficult to define. Because the deeper humanity studies the universe, the larger reality appears to become. For most of human history, people believed the stars were small lights fixed above Earth. Ancient civilizations imagined a relatively compact cosmos, a sky stretching only a short distance overhead. But every century, every telescope, every scientific discovery expanded the known scale of existence farther and farther outward. First, humanity realized Earth was not the center of the solar system. Then we discovered the sun was only one star among many. Then came the realization that the Milky Way itself was not the entire universe. And even today, the true size of existence remains unknown. The observable universe has a measurable size, but the total universe may be vastly larger, possibly infinite, and infinity creates strange consequences. Imagine traveling in a straight line forever, no matter how far you go, past galaxies, past clusters, past superclusters. There may never be an edge, no wall, no boundary, no final star, only more universe continuing endlessly. The human brain evolved to understand forests, mountains, rivers, and distances walked on foot. It did not evolve to emotionally process billions of light years. Even numbers themselves begin losing meaning at cosmic scales. Consider this carefully. The Earth is approximately 12,742 kilometers wide. The Sun is about 109 times wider than Earth. The distance from Earth to the Sun is about 150 million kilometers, already enormous. Yet if the Sun were reduced to the size of a white blood cell, Earth would orbit several meters away, and Neptune would be over 100 meters distant. The solar system is mostly empty space, but the solar system itself is tiny compared to interstellar distances. The nearest star beyond the Sun, Proxima Centauri, lies over 4 light-years away. That distance is so immense that if the Sun were the size of a grain of sand, the nearest star would still be hundreds of kilometers distant. Stars are not packed closely together. Galaxies appear bright because they contain unimaginable numbers of stars. Now imagine scaling upward again. The Milky Way contains perhaps 100 to 400 billion stars. Its diameter stretches roughly 100,000 light-years. If you could travel around the Milky Way at the speed of a modern passenger airplane, The journey would take over 100 billion years, longer than the current age of the universe itself. And our galaxy is not unusual. Some galaxies are vastly larger. The galaxy IC 1101, one of the largest known galaxies, stretches nearly 6 million light-years across. It contains perhaps 100 trillion stars. Trying to comprehend that number is almost impossible. If every star inside that galaxy represented 1 second, counting them would require millions of years. And galaxies themselves are separated by tremendous voids. The nearest large galaxy, Andromeda, sits approximately 2.5 million light-years away. A spacecraft traveling at the speed of Voyager 1, one of the fastest human-made objects ever built, would need roughly 70,000 years just to leave our solar system completely. Reaching Andromeda at that speed would take tens of billions of years, longer than stars survive, longer than civilizations endure. The universe is not merely large, it is staggeringly inaccessible. Now imagine the observable universe from the largest known scales. Astronomers have mapped immense structures containing thousands of galaxies linked together across hundreds of millions of light-years. One such structure, the Hercules Corona Borealis Great Wall, may stretch over 10 billion light-years in length, a structure so enormous that light itself needs billions of years to cross it. And yet even this colossal arrangement is only a tiny fraction of the observable universe. The observable universe spans approximately 93 billion light-years in diameter, not because the universe is 93 billion years old, but because space itself expanded while light traveled through it. The galaxies whose light first began traveling toward us billions of years ago are now vastly farther away than the original distance the light crossed. Space stretches continuously. The universe grows larger every second. Even empty space expands. Imagine dots drawn on the surface of an inflating balloon. As the balloon expands, every dot moves away from every other dot, not because the dots travel across the surface, but because the surface itself grows. This is similar to cosmic expansion. Galaxies move apart because space between them expands, and on sufficiently large scales, there is no absolute center. Every galaxy sees distant galaxies moving away. Every region of space participates in expansion. Now consider something even stranger. The observable universe may contain roughly 2 trillion galaxies, but because the universe may be infinite, there could be infinitely more beyond what we can observe. No telescope can see beyond the observable horizon because light from those regions has not had enough time to arrive. The observable universe is not necessarily the entire universe. It is simply the visible portion, like standing on a beach at night with a lantern. The illuminated sand is not all the sand that exists, only the portion your light reaches. Beyond the darkness, the beach may continue endlessly. Now think about how small humanity becomes within these scales. The average human lifespan is perhaps 80 years. Compared to cosmic time, this is almost nothing. Light itself can cross Earth 7 times in 1 second. Human civilizations rise and fall in periods shorter than the movement of stars around the galaxy. The Sun requires approximately 225 million years to complete one orbit around the Milky Way. Dinosaurs appeared and vanished during only part of a single galactic year. Human civilization occupies a tiny fraction of that already tiny interval. The universe moves on scales almost entirely detached from human experience. And still, the cosmos grows even larger when we study time itself, because looking deeper into space also means looking farther into the past. The moon appears as it was about 1 second ago. The sun appears 8 minutes old because its light needs 8 minutes to reach Earth. When you observe Jupiter, you see it as it existed tens of minutes earlier. When astronomers observe distant galaxies billions of light years away, they witness ancient cosmic history. Some galaxies observed by modern telescopes emitted their light before Earth even formed. The farther we see, the younger the universe appears. Eventually, telescopes detect faint radiation filling all of space itself. The cosmic microwave background. Ancient light released roughly 380,000 years after the beginning of cosmic expansion. A faint afterglow of the early universe. Tiny fluctuations inside that ancient radiation eventually became galaxies, stars, planets, and life. Humanity discovered that the entire visible cosmos evolved from minute variations in density present nearly 14 billion years ago. All cosmic structure emerged from those tiny irregularities, and still, scientists continue uncovering larger scales. The observable universe contains filaments of galaxies stretching across incomprehensible distances. These structures resemble a vast cosmic web, clusters linked together like glowing threads. Between them lie enormous voids where almost no galaxies exist. Some voids stretch hundreds of millions of light years wide. If the Milky Way were placed inside one of these regions, nearby galaxies might be so distant that intelligent life there could struggle to detect the larger universe at all. Entire civilizations might believe they exist alone in darkness. The scale of the universe influences what can even be known. Now imagine shrinking the Milky Way down to the size of North America. The solar system would become microscopic, Earth itself smaller than a virus, human beings utterly invisible, and yet every war, every empire, every language, every religion, every piece of music, every story humanity has ever told occurred on a world smaller than dust compared to the galaxy, and the galaxy itself becomes almost nothing compared to the observable universe. If the Milky Way were reduced to the size of a dinner plate, the observable universe would still span thousands of kilometers. These comparisons fail emotionally because the true scale exceeds ordinary intuition. The universe is so large that certain events become statistically inevitable. Given enough stars, enough planets, enough time, there may be countless worlds with oceans, countless worlds with life, perhaps even countless intelligent civilizations. The Milky Way alone may contain billions of potentially habitable planets, and the observable universe contains trillions of galaxies. The numbers become almost absurd. Yet despite these immense possibilities, the distances remain brutal. Even if intelligent civilizations are common, they may remain forever isolated by cosmic scale. Signals weaken across enormous distances. Travel between stars requires immense energy and time. Galaxies themselves drift farther apart due to expansion. The universe may contain abundant life, while still remaining profoundly lonely. Now consider another astonishing fact. The atoms inside your body are mostly empty space. If every atom were enlarged so that its nucleus became the size of a marble, the electrons would orbit hundreds of meters away. Matter itself is largely emptiness, and the universe on its largest scales mirrors this structure. Galaxies drift through vast emptiness just as electrons drift around atomic nuclei. Reality repeats patterns across scale, tiny structures, immense structures, nested layers of emptiness and energy extending across unimaginable ranges of size. Humanity exists roughly in the middle, larger than atoms, smaller than galaxies, suspended between microscopic quantum worlds and cosmic superstructures. And beyond all these scales, the universe may continue forever. No final galaxy, no final darkness, no final distance, only endless expansion into deeper and deeper immensity. And as your breathing slows, and your mind drifts quietly through these enormous cosmic distances, we continue traveling outward, toward scales even larger than galaxy superclusters, toward horizons where observable reality itself begins to fade into the infinite unknown. beyond galaxy clusters, beyond superclusters, beyond the largest known cosmic structures. The universe continues expanding into scales so immense that ordinary language begins to fail completely. Human beings naturally understand size through comparison. A mountain is larger than a tree. A planet is larger than a mountain. A star is larger than a planet. But eventually, the differences become so extreme that comparison stops helping. The observable universe contains distances so vast that even using light, the fastest thing known, still results in travel times measured in billions of years, and light moves extraordinarily fast. In a single second, light could circle Earth more than 7 times. It reaches the moon in about 1.3 seconds. It reaches the sun in about 8 minutes. Yet even at that speed, light needs over 4 years to reach the nearest star, 100,000 years to cross the Milky Way, millions of years to travel between neighboring galaxies, billions of years to cross the observable universe. The cosmos is built on scales so enormous that even light struggles against them. Now, imagine reducing Earth to the size of a single grain of sand. At that scale, the sun would become a sphere roughly the size of a large orange several meters away. Jupiter would orbit dozens of meters distant, Neptune hundreds of meters away, and the nearest star beyond the sun would still be thousands of kilometers away. That is how empty interstellar space truly is. Galaxies appear crowded in photographs because telescopes compress unimaginable depth into flat images, but reality is mostly vacuum, mostly darkness, mostly distance. Even inside galaxies, stars almost never collide because the space separating them is so immense. If 2 galaxies pass through one another during a galactic merger, most stars simply drift by without direct contact. The emptiness protects them. Space is dominated not by objects, but by absence. Now imagine scaling upward again. Suppose the Milky Way galaxy were reduced to the size of Earth. At that scale, the observable universe would still be vastly larger than the solar system, and beyond the observable universe, possibly infinitely more. Some cosmologists estimate that the total universe, if finite, could still be many orders of magnitude larger than the observable portion, perhaps trillions upon trillions of times larger, or perhaps truly infinite, and infinity changes the nature of reality itself. In an infinite universe, even extraordinarily unlikely events may eventually happen somewhere. Another Earth, another Milky Way, another arrangement of atoms identical to your body. The distances required would be so incomprehensibly large that no human language comfortably describes them. Numbers themselves begin breaking intuition. 1,000,000 seconds equals about 11 days. 1,000,000,000 seconds equals about 31 years. 1,000,000,000,000 seconds equals over 31,000 years. Now imagine scales vastly beyond trillions. Astronomy forces the human mind into numerical territories evolution never prepared us to inhabit. The observable universe alone may contain around 10 sextillion stars. That is approximately 10 sextillion stars, a number so large that writing it out already feels unreal, and many of those stars possess planetary systems. Recent discoveries suggest planets may outnumber stars. The night sky may contain more worlds than grains of sand on every beach on Earth. Now pause for a moment and imagine that. More planets than all the grains of sand on Earth. Rocky planets, gas giants, frozen worlds, ocean planets, some orbiting red dwarf stars that burn for trillions of years, some circling dead stellar remnants, some wandering through interstellar darkness completely alone without any star at all. Rogue planets drifting endlessly through black space, entire worlds without sunrises, without sunsets, without warmth, only frozen silence beneath distant stars. And still, All of this exists within merely the observable portion of the universe. Now let us consider the limits of observation itself. Humanity cannot directly see infinitely far because the universe has a finite age. The observable universe acts like a sphere centered around every observer. Wherever intelligent life exists, observers there would also see themselves near the center of their own observable region, not because they occupy a special location, but because light has only traveled a limited distance since the beginning of cosmic expansion. This means there is no known center to the universe, no privileged location. On large scales, every region appears similar. The cosmos may not have an edge in the ordinary sense, just horizons beyond which information cannot yet reach us. And these horizons continue changing. Because space expands, some galaxies visible today will eventually become unreachable forever. Their future light will never arrive. Over immense timescales, distant galaxies gradually disappear beyond the cosmic horizon. Future civilizations trillions of years from now may observe a far emptier sky. They might never realize the universe once contained countless galaxies. Evidence of cosmic expansion could vanish from observation entirely. Humanity exists during a rare era when the universe is still observable on grand scales, an extraordinarily fortunate moment in cosmic history. Now imagine the timeline of the universe compressed into one calendar year. The Big Bang occurs at midnight on January 1st. The Milky Way forms around March. The solar system forms in early September. Dinosaurs appear near Christmas. Human civilization emerges during the final seconds before midnight on December 31st. All recorded history occupies only a tiny fraction of the final moment. Human lives become almost invisible against cosmic time. And still, the future stretches incomprehensibly farther. Some stars, especially small red dwarfs, may survive for trillions of years, far longer than the current age of the universe. The cosmos has barely begun its lifespan. Humanity lives during the early stellar era, an era rich with bright stars and active galaxies. Future epochs may look entirely different. Eventually, galaxies may exhaust the gas needed to create new stars. The universe could slowly darken over unimaginable spans of time. White dwarfs cooling, neutron stars fading, black holes dominating the cosmic landscape. Yet even black holes are not eternal. According to current physics, black holes may slowly evaporate through Hawking radiation. The largest black holes could survive for numbers of years so enormous that writing them fully becomes impractical. Some estimates exceed 100 years, a Google years, far beyond any ordinary scale of comprehension. Compared to those durations, the current age of the universe becomes microscopic. Humanity often imagines the universe as ancient, but relative to the deepest cosmic future, the universe may still be extraordinarily young. Now think about scale in another way. The observable universe contains roughly 2 trillion galaxies. Suppose every galaxy were reduced to the size of a single cell inside a human body. The resulting cosmic organism would still dwarf planetary scales beyond imagination. Or imagine every star represented by 1 grain of sand. The stars in the observable universe would create mountains vastly larger than Earth's tallest ranges. Physical analogies fail because the universe exceeds ordinary experience by too many orders of magnitude. Even emptiness possesses scale. The largest cosmic voids span hundreds of millions of light years. If the Milky Way were placed at the center of one of these voids, neighboring galaxies might appear tiny and sparse across the sky. An intelligent civilization there could spend millions of years developing astronomy before realizing larger cosmic structures even existed. Distance shapes knowledge. The scale of the universe limits what civilizations can discover, and the speed of light imposes a universal delay on information. Every observation is observation of the past. Astronomy is fundamentally time travel through vision. When the James Webb Space Telescope observes extremely distant galaxies, it captures light emitted shortly after the first stars formed. Humanity is literally observing ancient cosmic dawn. Some of those galaxies appear surprisingly mature for their age, forcing scientists to reconsider parts of cosmological theory. Even now, our understanding evolves. The universe remains larger and stranger than expected, and still, there are scales even beyond galaxies and cosmic webs. The observable universe itself may be only a tiny bubble inside a vastly greater structure. Some theories propose inflationary cosmology created immense regions of space expanding beyond observation. Other theories suggest multiple universes constantly emerge through quantum processes. If true, existence may contain endlessly nested levels of reality, extending far beyond the visible cosmos. But even restricting ourselves only to the observable universe, the scale already overwhelms comprehension. A human being standing beneath the night sky sees only a tiny fraction of the stars in our own galaxy. The naked eye reveals perhaps several thousand stars under perfect darkness. Yet the Milky Way contains hundreds of billions, and beyond it lie trillions of other galaxies. The visible night sky is only the thinnest glimpse of reality, a tiny window opening onto immensity. And as you continue relaxing, breathing slowly, drifting peacefully through these enormous cosmic distances, we move farther still, toward the deepest measurable scales ever studied by science, toward the limits where mathematics, space-time, and infinity begin merging together, toward realities where even eternity itself may become only one layer inside a greater cosmic structure. Because the farther humanity pushes scientific understanding, the more the universe appears to transcend ordinary categories entirely. Not only larger than expected, but larger than human intuition can naturally contain. The observable universe already stretches across distances so immense that light moving at nearly 300,000 kilometers every second still requires billions of years to cross it. And yet observable space may represent only a limited visible region inside something vastly greater, possibly infinite, possibly eternally expanding, possibly generating new cosmic regions forever. Now imagine the observable universe again. A sphere roughly 93 billion light-years across, containing ancient radiation from the early cosmos, containing galaxies spread through immense filaments and voids, containing perhaps 2 trillion galaxies, each galaxy filled with stars. Many stars surrounded by planets. Already the scale overwhelms comprehension. Yet modern cosmology asks whether this entire observable region may itself be cosmically small, a local bubble inside a larger inflating structure. Now think carefully about the difference between large and infinite. A trillion is enormous. A Google is vastly larger, but infinity is not simply a bigger number. Infinity means there is no final amount, no largest count, no terminal distance. If space-time truly extends infinitely, then there is no ultimate galaxy beyond which nothing exists, no final darkness, no cosmic wall, only endless continuation. Human intuition struggles because every environment humans evolved within possessed boundaries, but physical reality may not. Now imagine traveling forever through an infinite universe, passing galaxies endlessly, clusters appearing and fading, ancient stars dying, new stars igniting, cosmic structures emerging across unimaginable expanses. No matter how long the journey continued, there would always remain farther regions ahead. The concept itself feels emotionally impossible because the human brain evolved to survive finite environments on Earth, not infinite space-time. Now consider the largest distances directly measurable by science. The cosmic microwave background comes from a time roughly 380,000 years after the Big Bang. That ancient light traveled for nearly the entire age of the universe before reaching Earth. Humanity observes photons older than every star in the Milky Way, older than Earth, older than the Sunday. The observable universe contains ancient light still crossing space after billions of years. Now think about scale through light travel again. If the Sun vanished suddenly, Earth would continue orbiting normally for approximately 8 minutes before the final sunlight disappeared. Gravity itself propagates at light speed. This means even causality unfolds slowly across cosmic distances. The universe is so large that no event becomes instantly known everywhere. Information spreads gradually through space-time. Now imagine a civilization existing near the edge of our observable universe. The light they currently observe from the Milky Way would show our galaxy as it existed billions of years ago. Earth itself might not even exist yet from their perspective. Every observer sees a different cosmic past depending on location. The universe distributes history across space itself. Now let us scale upward once more. The Milky Way spans roughly 100,000 light-years. Yet the local group containing nearby galaxies stretches millions of light-years across. The Virgo supercluster extends across more than 100 million light-years. Laniakea spans roughly 500 million light-years. And still these gigantic structures remain tiny compared to the observable universe. Human language repeatedly fails because each large structure becomes microscopic against the next scale upward. Reality contains hierarchy after hierarchy of size. Now consider how empty even the observable universe truly is. Most galaxies occupy tiny fractions of cosmic volume. Most of space-time consists of near-perfect vacuum. Even inside galaxies, stars remain separated by immense distances. If the Milky Way were compressed to the size of North America, the solar system would become far smaller than a single cell. Human beings utterly invisible, and yet the observable universe would still dwarf the planet. The scales refuse ordinary visualization. Now imagine the cosmic web evolving across time. Gravity slowly pulls matter into filaments. Galaxies collide. Clusters merge. Dark matter shapes invisible scaffolding beneath visible structure. Over billions of years, tiny fluctuations from the early universe grew into enormous formations spanning hundreds of millions of light-years. The largest structures in existence emerged gradually from microscopic quantum irregularities amplified through cosmic inflation. Tiny beginnings producing gigantic outcomes. Now think about the earliest measurable moment in cosmic history. The observable universe once existed in a state smaller, denser, and hotter than anything humans experience naturally. Space itself expanded from that early state, not an explosion inside empty space, but expansion of space-time itself. Every region expanding simultaneously, and during inflation, the universe may have expanded exponentially in tiny fractions of a second. Microscopic quantum fluctuations stretched across astronomical distances. Those fluctuations later became galaxies. In a profound sense, the largest structures in the universe originated from quantum-scale irregularities. The cosmos links the infinitely small with the unimaginably large. Now consider another astonishing implication of infinity. If the universe is spatially infinite and matter distribution statistically uniform, then finite arrangements of particles must eventually repeat. The observable universe contains finite configurations of matter because quantum states remain finite within finite volume. Across infinite space, those configurations recur, not nearby, not even remotely nearby, but somewhere beyond unimaginable distances. Another observable universe statistically identical to ours may exist. Another Earth, another Milky Way, another civilization studying cosmology beneath another sky. Infinity changes probability into inevitability. Now think about how large the number of possible planets already is inside the observable universe alone. Astronomers estimate planets may outnumber stars. If the observable universe contains around 10-24 stars, then worlds may number in the septillions or beyond. Some planets orbit dim red dwarfs lasting trillions of years. Some drift freely through interstellar darkness without stars. Some may contain oceans beneath kilometers of ice. Some may possess skies illuminated by multiple suns. The scale of planetary diversity likely exceeds all fictional imagination humanity has ever produced. And still, the distances between worlds remain immense. Even neighboring stars lie separated by years of light travel. Galaxies separated by millions. Clusters separated by vastly more. The universe may contain extraordinary abundance while remaining physically isolating. Now imagine the future universe again. Billions of years pass. Galaxies outside local groups disappear beyond observational reach. Star formation declines. White dwarfs cool. Black holes dominate. Trillions of years unfold. Yet expansion continues. Space grows larger and emptier. Eventually only faint remnants of stellar eras remain. And after unimaginable durations, even black holes may evaporate through Hawking radiation. The universe approaching extreme cold and darkness, yet perhaps still expanding forever. Now pause and consider the scale of those future times. The current age of the universe, 13.8 billion years. The lifespan of some red dwarf stars, 10 trillion years or more. The evaporation time for supermassive black holes, numbers approaching googles of years. Compared to such futures, humanity exists astonishingly early in cosmic history. The stellar age has barely begun. Now imagine observing the universe from impossible perspective outside space-time itself. Entire observable universes appearing like glowing bubbles, galaxies flickering inside them, inflation continuously generating new cosmic regions, endless space-time producing endless observable domains. Some theories suggest such structures may emerge eternally, reality continuously growing larger, not toward anything, not inside anything, simply expanding. Now think about what this means emotionally. Human concerns occupy tiny spans of time on tiny regions of space. Civilizations rise and fall during fractions of galactic rotation. Entire species appear and vanish while stars barely change. The universe moves on, scales profoundly detached from ordinary human urgency. Galaxies drift patiently across billions of years. Black holes wait longer than civilizations can imagine. Cosmic expansion unfolds silently regardless of human awareness. There is strange peace in that enormity. The universe does not hurry. Now consider again how remarkable it is that conscious observers emerged at all. On one small rocky world orbiting one ordinary star. Biological evolution produced minds capable of measuring galaxies billions of light years away. Tiny creatures constructed telescopes, detected ancient microwave radiation, calculated space-time geometry, measured expansion rates, discovered exoplanets, mapped large-scale structure. The cosmos became capable of studying itself, and perhaps somewhere across those immense distances, other conscious beings also gaze upward, asking the same questions, wondering how large existence truly is. Wondering whether space-time ever ends, wondering whether infinity is real. Now continue drifting quietly outward through the endless cosmic web, past superclusters, past observable horizons, past ancient radiation, toward infinite darkness perhaps filled with endless unseen galaxies, toward space-time stretching beyond all finite measurement, toward realities where even trillions of observable universes may represent only small fluctuations inside something larger still. And as your breathing slows, as your thoughts become quieter, we continue deeper into the immense structure of existence, toward scales where mathematics itself begins struggling to describe the true size of reality, toward the deepest measurable scales, toward distances so immense that even the observable universe may represent only a tiny fragment of reality. Humanity has attempted to measure the cosmos using mathematics, because ordinary intuition cannot survive these scales alone. Numbers become the only tools capable of reaching such immense distances, and even mathematics sometimes struggles. The observable universe contains roughly 93 billion light-years of measurable diameter. That means if you could somehow travel from one side of the observable universe to the other at the speed of light, without stopping, without slowing, without cosmic expansion increasing the distance further, the journey would still require approximately 93 billion years. More than 6 times longer than the universe has existed, and yet the observable universe is not considered especially unusual in cosmology. It is simply the region whose light has reached us so far. Beyond it, the universe may continue indefinitely. Now imagine something extraordinary. Every direction in space contains distant galaxies. No matter where telescopes look, galaxies appear almost everywhere. This suggests the universe on large scales is remarkably uniform. But uniform in cosmology still allows for unimaginable structure, gigantic clusters, enormous voids, filaments spanning hundreds of millions of light years. The universe resembles foam, or a vast, three-dimensional web. Galaxies gather along invisible gravitational scaffolding created largely by dark matter, and these structures continue beyond the edge of observation, possibly forever. Now consider how large a light-year truly is. 1 light-year equals approximately 9.46 trillion kilometers, a number already beyond ordinary human experience. If a person drove a car continuously at highway speed toward the nearest star, the trip would take tens of millions of years. Modern human civilization itself is only several thousand years old. Humanity has not existed long enough even to begin comprehending interstellar travel emotionally. And still, interstellar distances are tiny compared to intergalactic scales. The gap between the Milky Way and Andromeda alone is about 2.5 million light-years. The Virgo cluster, a collection of thousands of galaxies, lies roughly 55 million light-years away. The observable universe extends billions of light-years farther still. Now imagine compressing the Milky Way down to the size of a coin. At that scale, the solar system becomes microscopic beyond visibility. Earth smaller than a bacterium, a human body smaller than atoms could reasonably represent. And yet the observable universe would still span thousands of kilometers. This is the difficulty of cosmic scale. Everything familiar vanishes into insignificance almost immediately. Now think about how ancient the universe is. Approximately 13.8 billion years. That number alone feels enormous. But cosmological time extends much farther into the future. Some estimates suggest the final black holes may evaporate only after durations like 10, 100 years, a Google years. Writing the number fully requires 1 followed by 100 zeros. And even that may not represent the end of reality. Some cosmological theories suggest eternal expansion. Others suggest cyclic universes. Others describe quantum fluctuations continuously generating new regions of spacetime forever. Humanity may inhabit only one temporary region inside an endless cosmic process. Now consider another astonishing scale. The observable universe may contain roughly 200 sextillion stars. That means 200 sextillion stars. If every star were reduced to a single grain of sand, the resulting collection would cover enormous regions of Earth. And around many of those stars orbit planets. Some studies suggest the Milky Way alone may contain billions of Earth-sized planets located within habitable zones. Multiply that by trillions of galaxies, and the number of potentially life-supporting worlds becomes almost incomprehensible. Yet because of cosmic distances, even neighboring civilizations could remain forever separated. Signals weaken, travel times become extreme. The universe may contain extraordinary abundance alongside extraordinary isolation. Now let us examine the observable horizon more carefully. The universe has no known visible edge like the surface of a wall. Instead, observers encounter a horizon created by time itself. Light travels at finite speed. Because the universe has existed for a finite duration, only a limited amount of information has had time to arrive. There are regions whose light is still traveling toward us right now, regions completely invisible to present-day humanity. And some regions may remain permanently unreachable because expansion outpaces the travel of light itself. The observable universe continuously changes. New ancient light arrives. Other regions disappear beyond causal contact. The cosmos is dynamic even on its largest scales. Now imagine standing somewhere billions of light years away. From there, Earth would not appear visible at all, not even with immense telescopes. Our entire planet would vanish into the brightness of the Sunday. And from farther away, even the sun disappears among billions of other stars. From sufficiently distant regions, the Milky Way itself becomes only a faint point of light. The farther outward one travels conceptually, the smaller everything familiar becomes. Now think about this carefully. Humanity often imagines itself large because human experience fills human awareness. Cities feel enormous. Mountains feel immense. Oceans appear endless. But compared to planetary scales, cities vanish. Compared to stellar scales, planets vanish. Compared to galactic scales, stars become nearly invisible. Compared to cosmic scales, galaxies themselves shrink into tiny points, scattered across darkness. Reality contains nested hierarchies of size extending far beyond intuition. And yet, even the largest known structures may not represent the true upper limits of existence, because the observable universe itself could merely be one region among infinitely many. Some inflationary models suggest space-time expanded exponentially during the earliest moments of cosmic history. If true, enormous regions beyond observation may exist with similar structures to our own, possibly infinitely repeating, possibly governed by different physical conditions, possibly containing entirely different cosmic histories. The universe may be not merely large, but fundamentally boundless. Now consider something even stranger. Because space expands, some regions of the universe are already receding from us faster than light. This does not violate relativity because galaxies are not moving through space faster than light. Instead, space itself expands between them. Imagine ants standing on a stretching rubber sheet. The ants need not move at all for the distance between them to increase rapidly. On sufficiently large scales, space-time itself grows, and because expansion accelerates, very distant galaxies eventually become causally disconnected. Future observers in distant epochs may see only their local galaxy group surrounded by darkness. The broader universe could disappear from view entirely. Humanity lives during an era unusually rich in observable information, a brief cosmological window. Now let us explore size through another perspective. Suppose every meter represented one light year. At that scale, the moon would remain extremely close. The sun would lie 150 million meters away, but the nearest star beyond the sun would sit over 40 trillion meters distant, and the Milky Way would stretch across unimaginable planetary scales. No physical model comfortably captures cosmic proportions because the ratios become too extreme. The universe operates across scales spanning over 60 orders of magnitude, from quantum lengths smaller than atomic nuclei to cosmic distances measured across billions of light years. Human beings exist roughly near the middle of these scales, suspended between the infinitely small and the unimaginably large. Now imagine traveling outward forever, past galaxies, past clusters, past superclusters, past every observable structure. Would space continue endlessly? Current evidence suggests it might. A flat universe, according to modern measurements, may imply infinite spatial extent. If true, then somewhere beyond unreachable distances, matter arrangements repeat, not because of destiny, but because infinite space allows finite patterns to recur. Another Earth, another Milky Way, another night sky, possibly another version of this very moment, separated by distances so extreme that light itself could never bridge them before stars die and galaxies fade. Infinity transforms improbability into inevitability, and still, humanity understands only part of the cosmos. Dark matter remains invisible, dark energy remains mysterious, quantum gravity remains unresolved. The total topology of the universe remains uncertain. Whether space-time itself is finite or infinite remains unknown. Even the ultimate fate of the cosmos is still debated. Science continues expanding the boundaries of knowledge, while simultaneously revealing how vast the unknown truly is. The more humanity learns, the larger the universe becomes, and perhaps that is one of the deepest truths of all. The cosmos is not shrinking under explanation. It is growing. Every telescope reveals more galaxies. Every measurement uncovers deeper structure. Every answer opens larger questions. The observable universe already overwhelms human imagination, yet reality may extend infinitely beyond even that. And now, as your breathing becomes slower, as your thoughts drift farther outward through endless cosmic darkness, we continue deeper still, toward the ultimate measurable limits of space, toward the geometry of the universe itself, toward horizons where even the concept of size begins to lose meaning, toward horizons where even the idea of distance becomes uncertain. Because when scientists attempt to describe the true size of the universe, they eventually encounter a profound problem. The universe may not simply be large. It may be larger than size itself can comfortably describe. Human beings imagine space as something measurable. A room has walls, a city has boundaries, an ocean eventually reaches land, but the universe may not function that way. Modern cosmology suggests space itself could be curved, flat, finite, or infinite, in ways difficult to visualize using ordinary three-dimensional thinking. Imagine an ant walking across the surface of Earth. From the ant's perspective, the surface may appear endless. No edge, no wall, no boundary, yet Earth itself is finite. In a similar way, some models suggest the universe could possess higher dimensional curvature, allowing space to be finite without edges. You could theoretically travel forever without encountering a boundary. And if the universe is truly spatially infinite, then the consequences become even stranger. Infinite stars, infinite galaxies, infinite regions of space-time, possibly infinite repetitions of matter configurations. Not because the universe intentionally repeats itself, but because infinite volume combined with finite physical arrangements eventually produces recurrence. Now pause and think about how enormous merely the observable universe already is. The observable cosmos contains regions so distant that their light began traveling toward us before Earth existed. When telescopes observe galaxies billions of light years away, they are witnessing ancient stages of cosmic history. Some galaxies appear as they existed less than 1 billion years after the Big Bang. Astronomers are literally observing the early universe. Looking outward becomes identical to looking backward in time, and the farther telescopes improve, the deeper into the past humanity can see. The James Webb Space Telescope revealed galaxies astonishingly distant and ancient. Some appeared surprisingly massive and developed for such early cosmic times. Entire galaxies already existed while the universe itself was still young. This forces cosmologists to refine models of how quickly large structures formed. Even our understanding of cosmic scale continues evolving. The universe remains larger, older, and more complex than expected. Now imagine the observable universe not as empty darkness with scattered galaxies, but as a vast dynamic system shaped by gravity over billions of years. Matter gathered slowly into filaments. Galaxies formed enormous clusters. Clusters merged into superclusters, and between them stretched cosmic voids of staggering emptiness. The Boötes void, one of the largest known voids, spans roughly 330 million light-years. Inside such a region, galaxies become extraordinarily sparse. If the Milky Way existed there, the night sky would appear dramatically emptier. Intelligent civilizations within large voids might struggle to discover the broader cosmic structure because fewer nearby galaxies would exist for observation. The size of the universe influences perception itself. Reality changes depending on where observers exist within cosmic structure. Now let us think about motion across these distances. The fastest object ever created by humanity is tiny compared to cosmic scales. Voyager 1 travels roughly 61,000 kilometers per hour, an astonishing speed by human standards. Yet at that velocity, it would need over 70,000 years merely to approach the nearest star region, and crossing the Milky Way would require hundreds of millions of years. Human technology remains profoundly local within the cosmos. The universe is so large that even imagining travel becomes difficult. Light itself struggles against cosmic distance, and because the universe expands, some destinations are fundamentally unreachable, regardless of technology. Certain galaxies already recede too rapidly due to cosmic expansion. No spacecraft traveling at sublight speed could ever reach them. Even light emitted today may never arrive there. The observable universe contains permanent limits imposed by space-time itself. Now imagine compressing all human history into a single second. Compared to cosmic timescales, this would still feel too long. The universe existed for billions of years before Earth formed. Earth itself existed for billions before humans appeared. Modern civilization occupies only the thinnest fraction of cosmic history, and yet the future may continue vastly longer than the past. Some red dwarf stars may survive for trillions of years. Trillions, not millions, not billions, trillions. These small stars burn fuel extremely slowly. Long after stars like the Sun die, red dwarfs may continue glowing quietly across the darkness. Future civilizations, if they exist, may inhabit a universe very different from ours. A darker universe, a quieter universe, one where galaxies beyond local groups vanish permanently from view. Now think about observable size versus total size. The observable universe expands roughly 46.5 billion light-years outward in every direction from Earth. This creates the 93 billion light-year observable diameter. But the total universe could be vastly larger. Imagine standing in dense fog holding a lantern. The visible region around you is not all reality, only the portion whose light reaches your eyes. The universe beyond the observable horizon may continue endlessly. Modern measurements suggest space-time appears remarkably flat geometrically, and a perfectly flat universe often implies infinite extent. If correct, then space may continue forever. No edge, no end, no final galaxy, just endless cosmic structure extending beyond all possible observation. Infinity creates scales beyond emotional comprehension. If the universe is infinite, then somewhere impossibly distant, there may exist another observable universe, identical to ours. Another Earth, another Milky Way, another history, not through magic, not through parallel dimensions in science fiction, simply through probability distributed across infinite space. Now consider how many stars exist within only the observable portion. Astronomers estimate there may be more stars in the observable universe than grains of sand on all Earth's beaches combined. Every grain of sand representing a star, many with planets, some with entire systems vastly different from ours, planets orbiting binary stars, worlds covered entirely by oceans, frozen planets drifting through darkness, massive gas giants larger than Jupiter, rocky planets orbiting stars older than the Sunday. The scale of planetary diversity alone may exceed imagination, and still, stars themselves vary enormously in size. The Sun feels gigantic to humanity, yet some stars dwarf it completely. Scuti, one of the largest known stars, could contain the orbit of Jupiter inside itself. If placed where the Sun currently exists, its surface might extend beyond Mars. And yet even giant stars become tiny compared to galactic scales. Galaxies themselves range from dwarf galaxies containing a few billion stars to giant ellipticals containing trillions. Some black holes at galactic centers possess masses billions of times greater than the Sunday. The black hole in galaxy TON 618 may contain tens of billions of solar masses. Its event horizon alone could span distances larger than the solar system. The universe builds structures across scales almost impossible to visualize simultaneously. Atoms, humans, planets, stars, galaxies, clusters, superclusters, cosmic webs, possibly infinite space-time. Reality stretches across extraordinary layers of scale, and humanity exists in the middle, large compared to atoms, tiny compared to galaxies. Now imagine shrinking the observable universe down until the Milky Way becomes the size of a single cell. At that scale, Earth vanishes entirely. Human civilization becomes smaller than molecular structure. Everything humanity has ever accomplished disappears beneath the threshold of visibility. And yet conscious beings emerged within this enormous cosmos capable of measuring it. Tiny creatures on a small rocky planet discovered galaxies billions of light years away. They measured the age of stars, detected ancient radiation from the early universe, calculated expansion rates of space-time itself. The universe became aware of its own scale through conscious observation. Perhaps that is among the strangest scientific facts of all. Now let us consider the largest observable structures ever discovered. The cosmic web stretches across unimaginable distances. Galaxies gather into filaments hundreds of millions of light-years long. These filaments intersect at dense nodes where galaxy clusters form. Between them lie voids of near-total emptiness. The universe resembles foam viewed on incomprehensible scales, or perhaps neural pathways inside a colossal cosmic brain. Yet these patterns emerge naturally from gravity, acting across billions of years. Tiny density fluctuations in the early universe eventually evolved into vast structures spanning hundreds of millions of light years. The largest scales of existence grew from almost imperceptible differences in matter distribution shortly after the Big Bang. And even now, these structures continue evolving. Galaxies collide, clusters merge, dark matter shapes motion invisibly. Space expands relentlessly. The universe is not static. It changes continuously across cosmic time. Now imagine looking so far outward that individual galaxies blur together. The observable universe itself becomes a glowing sphere of ancient light. Beyond it, darkness, not because nothing exists, but because light has not yet arrived, and perhaps never will. Humanity's cosmic horizon defines the boundary of observable knowledge. There may always remain regions forever inaccessible to observation, not because science fails, but because space-time itself imposes limits. And still, the scale already visible surpasses comprehension. Billions of galaxies, trillions of planets, distances measured in billions of light years, timescales extending into trillions upon trillions of years, all unfolding within one universe. perhaps one among infinitely many. And as your breathing grows slower, as your mind drifts quietly through these endless cosmic distances, we continue outward, toward even deeper questions about the structure of space-time itself, toward the geometry of infinity, toward scales where the observable universe may become only a tiny fragment of something vastly larger, toward scales where even the observable universe may resemble a single grain of dust inside a far greater reality. Because one of the most astonishing discoveries in modern cosmology is this: the universe visible to humanity may not be especially large compared to the totality of existence. The observable universe feels infinite to the human mind, 93 billion light-years across, containing trillions of galaxies. Yet observation itself creates a limit, a horizon, and beyond that horizon, reality may continue far beyond anything human beings can directly measure. Now imagine standing inside an enormous forest covered in thick fog. You can only see a certain distance in every direction. Trees fade into whiteness beyond visibility, but the forest itself may continue for thousands of kilometers. The observable universe functions similarly. Humanity sees only the region whose light has had enough time to arrive since cosmic expansion began. Beyond that, the universe may continue endlessly. Modern measurements of cosmic geometry suggest the universe appears remarkably flat on large scales. And this detail matters enormously, because a perfectly flat universe often implies spatial infinity, not curved back onto itself like a sphere, not folded into a closed structure, but potentially endless. If true, then no matter how far one traveled, there would always be more space ahead, more galaxies, more stars, more darkness, forever. Now pause for a moment and truly imagine what infinity means physically, not metaphorically, not poetically. Actual infinite space, an endless number of galaxies extending beyond all possible observation. No edge, no center, no outer wall, no final structure, only continuous space-time stretching beyond comprehension. Human beings instinctively search for boundaries because every environment on Earth contains them. Rooms end, mountains end, atmospheres end, planets end. But the universe itself may not possess an ending at all. And if space truly extends infinitely, then the amount of matter may also be infinite. Infinite stars, infinite planets, infinite cosmic histories unfolding simultaneously across unreachable distances. Now consider another extraordinary consequence. There are only finitely many ways matter can arrange itself within a given volume according to quantum mechanics. This means that across infinite space, certain configurations may eventually repeat, not frequently, not nearby, but somewhere beyond unimaginable distances. A region identical to our observable universe may statistically exist somewhere far beyond the cosmic horizon. Another Milky Way, another Earth, another history nearly identical to this one. The distances involved become absurdly immense, far beyond billions or trillions of light years, numbers so enormous that ordinary notation becomes impractical, and yet mathematically, infinity allows such repetition naturally. Now think about the observable universe itself as a physical object. The radius of the observable universe is approximately 46.5 billion light-years. But this creates a strange question. How can the universe be only 13.8 billion years old if observable regions are farther away than 13.8 billion light-years? The answer lies in cosmic expansion. While light traveled toward us for billions of years, space itself expanded simultaneously. The galaxies emitting that ancient light are now vastly farther away than their original distance. The universe grew while light crossed it. Space itself stretches, and this stretching occurs everywhere, not into surrounding emptiness, but internally, Every large-scale region of space expands relative to others. Now imagine drawing tiny dots on a balloon. As the balloon inflates, every dot sees all other dots moving away. No dot occupies the center of expansion on the surface itself. Similarly, the universe does not require a central location. Expansion occurs throughout space-time. This concept remains deeply counterintuitive because human intuition evolved inside static terrestrial environments. The cosmos operates differently. Now consider the scale of galactic motion. The Milky Way and Andromeda move toward one another due to local gravity. But distant galaxies generally recede because cosmic expansion dominates at larger scales. Some galaxies move away so rapidly that their light becomes increasingly stretched into longer wavelengths. This phenomenon is called redshift. The farther a galaxy lies from Earth, the faster it usually recedes. This discovery transformed cosmology. It revealed that the universe is dynamic rather than static. And if the universe expands today, then in the distant past, matter must have been far closer together. This insight eventually led to modern Big Bang cosmology. Now think about the earliest observable light in existence, the cosmic microwave background, a faint glow filling all space. Released approximately 380,000 years after the Big Bang. Before that moment, the universe remained too dense and hot for light to travel freely. But as expansion cooled the cosmos, atoms formed, and light finally escaped into space. That ancient radiation still surrounds humanity today. Every direction in the sky contains this faint microwave glow, a remnant of the young universe itself. The observable cosmos is so large that ancient light from nearly the beginning of time still travels through space billions of years later. Now let us scale upward again. The Milky Way spans roughly 100,000 light-years. Yet galaxies themselves belong to larger gravitational systems. The local group contains the Milky Way, Andromeda, Triangulum, and dozens of smaller galaxies. The local group stretches roughly 10 million light-years across, but it too belongs to a larger structure called the Virgo supercluster. And beyond that lies the even larger Laniakea supercluster, containing approximately 100,000 galaxies across more than 500 million light-years. And still, these structures form only tiny threads inside the cosmic web. The universe builds hierarchy upon hierarchy of scale. Planets orbit stars. Stars gather into galaxies. Galaxies gather into clusters. Clusters form superclusters. Superclusters connect through filaments. Filaments stretch across observable space. And beyond observable space, possibly infinitely more structure continues. Now imagine shrinking the observable universe until it becomes the size of Earth. At that scale, the Milky Way would become microscopic, the solar system vastly smaller still, humanity effectively non-existent. The proportions become so extreme that no physical model comfortably captures them. Even the largest maps humanity creates represent only abstractions. Reality itself exceeds intuitive visualization. Now think about cosmic emptiness. Most of the universe contains almost nothing. Even galaxies are mostly vacuum. The distance between stars is immense. The distance between galaxies greater still. And the cosmic voids separating superclusters become almost perfectly empty. Some voids contain only a tiny fraction of the average cosmic matter density. A spacecraft drifting through one of these regions might travel millions of light-years without encountering a major galaxy. The universe is dominated not by matter, but by emptiness. Yet gravity slowly organizes matter across these enormous distances. Over billions of years, tiny density differences amplified into vast structures. The cosmic web emerged gradually through gravitational attraction. Dark matter played a crucial role. Without dark matter, galaxies may never have formed properly. and dark matter itself remains invisible. Humanity detects its gravitational influence, yet still does not know its exact nature. Most matter in the universe may consist of something fundamentally unfamiliar. Now consider dark energy, perhaps the most mysterious large-scale phenomenon known. Dark energy appears to drive accelerating cosmic expansion. Not only does the universe expand, the expansion speeds up over time. Galaxies increasingly race away from one another. The future universe may become progressively darker as distant structures disappear beyond observable reach. Billions or trillions of years from now, future observers may see only their local galaxy groups surrounded by darkness. The wider universe may become undetectable. Humanity exists during a cosmological era uniquely suited for discovery. A brief window when galaxies remain visible across vast distances. Now think about observable size from another perspective. Suppose every atom inside your body represented one galaxy. The number of atoms inside a human body still falls far short of the estimated number of stars in the observable universe. There are likely more stars in the cosmos than all grains of sand, all trees, all animals, and all human-made objects on Earth combined. The scale exceeds biological intuition completely. And yet, human consciousness evolved sufficiently to study these distances mathematically. Tiny organisms on a small rocky planet measured the expansion rate of the universe, mapped cosmic microwave radiation, calculated stellar evolution, detected planets orbiting distant stars, observed galaxies whose light began traveling before Earth formed. Consciousness reached outward across billions of light years. Perhaps that is one of the greatest scientific achievements in existence. Now imagine the night sky without cosmic distance. If stars were packed closely together, the sky would blaze constantly. Darkness itself exists partly because the universe has finite age and expanding structure. Many regions remain too distant for their light to arrive. Cosmic darkness reflects both scale and time. The black sky between stars is evidence of immense distance, evidence of finite cosmic history, evidence of expansion. Even darkness reveals the size of the universe. Now continue drifting outward mentally, past stars, past galaxies, past clusters, past superclusters, past observable horizons. Imagine endless space-time extending forever. Galaxies appearing endlessly in every direction. No boundary, no final destination. Only infinity unfolding across unimaginable silence. And somewhere inside that immensity, a small blue world circles an ordinary star inside one galaxy among trillions. And on that tiny world, tonight, a conscious mind quietly contemplates the scale of existence itself. And as your breathing becomes slower, as your thoughts dissolve gently into the vastness, we continue farther still, toward the deepest theories about infinite space, toward cosmological horizons beyond observation, toward scales where even entire universes may become tiny components of something larger, toward scales where even entire universes may become small structures inside a greater cosmic reality. Because when scientists investigate the largest possible scales of existence, the question eventually changes. No longer, how large is the observable universe? But instead, is the observable universe only one small region inside something vastly greater? Modern cosmology suggests this possibility cannot be ignored. The observable universe feels unimaginably enormous to human beings, yet mathematically, it may represent only a tiny, visible bubble inside a far larger space-time structure, perhaps infinitely larger. Now imagine standing in the middle of a gigantic ocean during dense fog. The visible horizon surrounds you in every direction. You might feel enclosed within a circular world, but the ocean itself extends vastly beyond what you can see. The observable universe works similarly. Humanity can observe only the region whose light has reached Earth since the beginning of cosmic expansion. That visible sphere moves with us. An observer in another galaxy would possess a different observable universe centered around themselves. There is no known universal center, only overlapping horizons of visibility, and beyond every horizon, more universe may continue. Now think about the sheer number of galaxies already visible within the observable region. Modern estimates suggest roughly 2 trillion galaxies may exist within the observable universe. 2 trillion galaxies, and each galaxy may contain millions, billions, or trillions of stars. The Milky Way alone contains perhaps 100 to 400 billion stars. Some giant elliptical galaxies contain more than 10 trillion stars. If every star were represented by 1 second of time, counting the stars inside certain galaxies would require hundreds of thousands of years, and those galaxies themselves are only tiny components of larger cosmic structures. Now imagine scaling upward once again. Galaxies cluster together through gravity. Clusters gather into superclusters. Superclusters connect through immense filaments of matter stretching hundreds of millions of light years. The cosmic web spans the observable universe like colossal threads woven through darkness. Some filaments contain thousands of galaxies linked across staggering distances, and between these filaments lie cosmic voids, regions so empty that millions of light years may pass with very few galaxies at all. The universe resembles an enormous sponge of matter and emptiness, or perhaps foam expanding endlessly through space-time. Now consider the observable universe itself as merely one region inside a potentially infinite cosmos. If space truly extends infinitely, then somewhere beyond the observable horizon, another cosmic web exists, another arrangement of superclusters, another ancient history unfolding beneath distant stars. And beyond that, more galaxies still, possibly forever. The scale becomes impossible to visualize because infinity is not merely very large. Infinity means there is no final number, no ultimate distance, no largest structure, no ending point where reality stops. Now pause and think carefully about what this means scientifically. Humanity may never know the total size of existence, not because science fails, but because physical laws limit observable information. Light travels at finite speed. Cosmic expansion stretches space-time. Some regions remain permanently beyond causal contact. There may always exist portions of reality fundamentally unreachable by observation. Even perfect technology could not overcome this limitation. The size of the universe may exceed not only human imagination, but human access itself. Now imagine traveling outward at the speed of light, past Earth, past the solar system, past neighboring stars, past the spiral arms of the Milky Way. Even after 100,000 years, our galaxy would still barely be crossed. Continue onward for millions of years. Galaxies drift past slowly through darkness. Clusters emerge, superclusters appear. Yet the observable universe still stretches billions of light years farther. And while traveling, expansion itself changes the distances. The cosmos is not static scenery. It evolves continuously. The map changes while the journey unfolds. Now think about ancient light. Some photons arriving at Earth tonight began traveling before multicellular life appeared on our planet. Others began their journey before the sun existed. The universe is so large that ancient light from the early cosmos still crosses space billions of years later. When telescopes observe distant galaxies, they do not merely see faraway objects. They see earlier eras of cosmic history. A galaxy 10 billion light years away appears approximately as it existed 10 billion years ago. Astronomy allows humanity to observe different epochs simultaneously. Nearby galaxies appear older in cosmic time. Distant galaxies appear younger. The observable universe functions like a layered archive of history spread across distance itself. Now imagine compressing the entire history of the universe into a single Earth year. The Big Bang occurs at midnight January 1st. The Milky Way forms months later. The solar system appears in September. Dinosaurs emerge near Christmas. Modern humans appear during the final minutes before midnight on December 31st. Recorded civilization occupies only the last seconds. A single human lifetime becomes almost immeasurably brief, and yet during that tiny interval, human beings measured galaxies billions of light years away. The scale of scientific discovery compared to the brevity of civilization is astonishing. Now consider something even more extraordinary. The observable universe may contain around 10-24 stars, 1 septillion stars, and because planets appear common, the number of worlds may exceed that. There may be more planets in the observable universe than all grains of sand on Earth by enormous margins. Rocky planets, ice giants, ocean worlds, rogue planets drifting starless through darkness. Some worlds orbit pulsars. Some orbit binary stars. Some may possess skies entirely unlike anything seen on Earth. The scale of planetary diversity likely exceeds human imagination, yet the distances between them remain immense. Even within the Milky Way, radio communication between civilizations could require centuries or millennia. The universe may be filled with worlds, while still remaining profoundly silent. Now let us think about the geometry of the observable universe itself. Current measurements suggest space-time appears nearly flat. This conclusion comes from studying the cosmic microwave background, the ancient radiation left from the early universe. Tiny fluctuations inside that radiation reveal information about large-scale geometry. And so far, observations suggest the universe is astonishingly close to flat. If truly flat, space may extend infinitely, not curved, closed upon itself, not folded into a finite hypersphere, but endless, an infinite cosmic plane of galaxies and darkness stretching forever. Now imagine the consequences emotionally. No outer edge, no final star, no place where space-time ends. Even if humanity traveled forever, there would always remain farther distances ahead, more galaxies, more ancient light, more cosmic voids, more unimaginable structures beyond the horizon. Infinity transforms the universe from a destination into an endless process. Now consider another astonishing fact about scale. Atoms themselves are mostly empty space. Matter feels solid because electromagnetic forces resist compression. But physically, atoms contain tiny nuclei, surrounded by vast regions of emptiness. If an atom were enlarged to the size of a cathedral, its nucleus might resemble a grain of dust. Reality contains emptiness on nearly every scale. Atoms, solar systems, galaxies, cosmic voids. Structure emerges amid enormous expanses of vacuum, and humanity exists within this layered hierarchy of scale, larger than atoms, smaller than planets, tiny compared to stars, invisible compared to galaxies, and galaxies themselves nearly vanish against the observable universe. Now imagine reducing the observable universe to the size of Earth. At that scale, a galaxy would become microscopic, a star far smaller still, a human being impossible to represent physically. Everything familiar dissolves into insignificance against cosmic scale. And yet, human consciousness somehow arose capable of understanding these proportions mathematically. Tiny biological organisms discovered the age of the universe, measured expansion rates, mapped distant galaxies, detected ancient radiation from nearly the beginning of time. Reality became aware of its own immensity through conscious observers. Now think about how recent this understanding truly is. Less than a century ago, many people believed the Milky Way might constitute the entire universe. Only in the 1920s did Edwin Hubble demonstrate that distant nebulae were actually separate galaxies far beyond our own. Suddenly, the universe expanded enormously overnight in human understanding, and ever since then, the cosmos has continued growing larger with every generation of observation. New telescopes reveal deeper distances, larger structures, earlier galaxies, more planets, more complexity. The universe consistently exceeds expectations. Now imagine future discoveries. Perhaps even larger cosmic structures await detection. Perhaps new theories about inflation or quantum gravity will reshape understanding again. Perhaps the observable universe itself is only one bubble inside a vast multiverse. Some inflationary models suggest space-time may continuously generate separate expanding regions, individual universes with potentially different physical conditions. If true, existence may contain endless cosmic bubbles emerging eternally across unimaginable meta-space-time, and our observable universe would become only one tiny region among countless others. Even the largest known scales may not be ultimate scales at all. Now continue drifting quietly through these immense distances, galaxies glowing faintly across darkness, ancient photons crossing billions of years, cosmic expansion stretching space-time silently, infinite horizons remaining forever beyond observation. And somewhere within that immensity, Earth continues orbiting an ordinary star inside one galaxy among trillions, a tiny world beneath endless cosmic depth. And as your breathing slows further, as your thoughts become softer and quieter, we continue outward still, toward the deepest measurable horizons of cosmology, toward inflation, toward eternal expansion, toward the possibility that reality itself may extend beyond all conceivable size, toward the possibility that reality itself may extend beyond all conceivable scale, because the deeper cosmology explores the universe, the more extraordinary the implications become. The observable universe already surpasses ordinary comprehension, yet many scientific models suggest that what humanity can observe may represent only a tiny fraction of total existence, and this possibility emerges naturally from physics itself, not from fantasy, not from mythology, but from measurements, mathematics, and the observed expansion of space-time. Now imagine the earliest moments of cosmic history. A fraction of a second after the Big Bang, the universe may have undergone a period called cosmic inflation. During inflation, space-time itself expanded at astonishing speed, far faster than the speed of light, not because matter moved through space faster than light, but because space itself expanded. Tiny quantum fluctuations present during that era stretched across enormous distances. Those tiny fluctuations later became galaxies, clusters, and cosmic structure. Everything humanity sees today may ultimately trace back to microscopic irregularities amplified by inflation. And if inflation occurred once, some theories suggest it may continue elsewhere indefinitely. This concept is called eternal inflation. In eternal inflation models, space-time continuously generates expanding regions, separate cosmic domains often described as bubble universes. Our observable universe would be only one such region, a tiny bubble inside a vastly larger inflating space-time, perhaps infinitely larger. Now pause and imagine scale at this level. Not billions of galaxies, not trillions of stars, but entire observable universes emerging across enormous cosmic expanses, each potentially containing its own galaxies, stars, planets, and histories. Some regions may possess physical constants slightly different from ours. Others may remain forever empty. Others may produce structures completely unlike anything familiar to humanity. The scale becomes so immense that the observable universe itself begins feeling small. Now consider another important scientific fact. The observable universe contains approximately 1080 atoms. That number is called the Eddington number, a 1 followed by 80 zeros, already far beyond ordinary human intuition. Yet compared to the possible scale of inflationary cosmology, even 1080 atoms may represent an insignificant quantity. The mathematics of inflation can generate regions vastly larger than the observable cosmos. Some estimates imply total space-time volumes so enormous that ordinary numerical notation becomes nearly meaningless. Now imagine the observable universe reduced to the size of a single grain of sand. Certain inflationary models suggest the total inflating cosmos could still exceed planetary scales by unimaginable margins. Human intuition simply collapses under such comparisons. The universe operates beyond evolutionary comprehension. Now think carefully about observable limits. The observable universe measures about 93 billion light-years across. But this does not necessarily mean the total universe is 93 billion light-years wide. It simply means that light beyond that distance has not had sufficient time to arrive since cosmic expansion began. The actual universe could be thousands of times larger, millions of times larger, infinitely larger. Current observations cannot determine the full extent. Humanity sees only a finite cosmic horizon. Now consider the relationship between scale and loneliness. The universe may contain countless planets capable of supporting life, perhaps countless intelligent civilizations, yet cosmic distances create profound separation. Signals weaken over light years. Travel between stars becomes enormously difficult. Galaxies themselves drift farther apart. The cosmos may overflow with life, while remaining nearly silent. Vastness itself isolates. Now imagine standing beneath perfectly dark skies far from cities. The Milky Way stretches overhead like pale mist. Thousands of stars become visible, yet what human eyes perceive represents only a tiny fraction of reality. Most stars remain invisible without telescopes. Most galaxies invisible entirely. Dark matter invisible. Dark energy invisible. Most of existence hidden beyond ordinary perception. And beyond observable horizons, perhaps infinitely more remains, forever unseen. Now think about how small Earth becomes against these scales. Earth circles one ordinary star inside one spiral galaxy among trillions. The solar system occupies a tiny region within the Orion arm of the Milky Way. The Milky Way itself drifts within the local group. The local group belongs to larger superstructures. Everything humanity has ever known occupies an almost immeasurably small region of cosmic space. Yet from that tiny region, consciousness emerged. Science emerged. Questions emerged. The universe became capable of contemplating its own size. Now, continue drifting outward mentally, past galaxies, past clusters, past observable horizons, into endless space-time, perhaps extending forever. No edge, no center, no final destination, only infinite cosmic depth unfolding silently across unimaginable darkness. And somewhere within that endless structure, Earth continues orbiting quietly around its star, a tiny blue world beneath a universe too large for complete comprehension. And as your breathing grows softer, as your thoughts dissolve gently into the vastness, here we stay, by the deepest cosmological possibilities, toward the ultimate implications of infinite space-time, at realities where even eternity itself may become only a small piece of the universe.